Hello everyone, myself Dr. Hemakumar. In this session, I will be discussing about type conversion storage classes used in C++. Type conversion in C++. A typecast is basically a conversion from one data type to another. There are two types of type conversion, that is implicit conversion and explicit type conversion. Implicit type conversion means that it is also known as automatic type conversion, done by compiler on its own without any external trigger from the user. Generally take place when it an expressions more than one data type is present. In such condition, type conversion, that is a type promotion, take place to avoid loss of data. All the data types of the variables are upgraded to the data type of the variable with the largest data type. For example, from boolean to char, char to short integer to integer. If you go with the unsigned integer to long, then long to unsigned. So if you go for the long, from the long it is go for float, from float to double, from double to long double. It is possible for implicit conversion to loss information. Signed can be lost when signed is implicitly converted to unsigned. And overflow can occur when long is implicitly converted to float. Carefully observe this slide. Here we are given a one program, sample program for the example as a type implicit conversion. We have written this as a hash include iostream.h using namespace std, then its integer main, open bracket, integer x equal to 10, char y is equal to a. We have assigned a as a value for a y and x we have assigned 10 as a value. The equation is x is equal to x plus y. X is implicitly converted to float, that is float z is equal to x plus 1. So if you do the output of x, y and z, the we will give the output will be given as x is equal to 107, where x values x is equal to x plus y. So x is a 10 and y a is equal to, will added the both the ASCII values assigned and it will be given as a 107, and then z value. So uh, y is given as a and z value will be given as 108 because z is equal to x plus 1. So x is 107, 107 plus 1 is added as a 108. This is how the automatically compiler will convert the lower level to higher level of uh, data types, and it will be worked out. Explicit type conversion. This process is also called typecasting and it is user defined. Here the user can typecast the result to make it of a particular data type. In C++, it can be done by two ways. One is converting by assignment, that is, this is done by explicitly defining the required type in front of the expression in parentheses. This can be also considered as a forceful casting. That is, for example, syntax we written as general syntax is type, which is written in a bracket, and the expression, where the type indicates the data type to which the final result is converted. Carefully observe this slide. We have given an example for C++ program to demonstrate explicit typecasting. In this explicit typecasting, we have written that hash include iostream using namespace std. Integer main program is called open bracket double x is equal to 1.2, integer sum is equal to int of x plus 1. We have written this x is a double we have declared, but here for the calculation for purpose the double is forcefully converted into integer type, and if you print that sum, the sum will give the value of 2 because x value is 1.2 plus 1. Integer will take only a integer part, not the real number 1.5. point 2 will be not considered, hence it will result will be 2. This type of conversion is called as a explicit type of conversion. So this will be happen with a forceful. We have seen the both implicit and explicit type conversion, but we have to understand that when to use each type of casting. Implicit conversion is automatic and safe type of conversion. Static casting is that for straightforward conversion between related types. Dynamic casting is for safe runtime, type checking and down casting. Constant casting is for adding or removing constant qualification. Reinterpretation casting is that for low level cast and pointer manipulation used with a caution. So basically we will be following the five types of different types of casting, that is implicit casting, static casting, dynamic casting, constant casting and reinterpreting casting. So the data type of hierarchy, we have shown here that the casting can be converted from low to high, that is from boolean to char, char to integer, integer to unsigned integer, unsigned integer to long, from long to unsigned long, from unsigned long to float, from float to double and double to long double. This type we will be using for the casting. Storage classes in C++. C++ storage classes are used to describe the characteristics of a variable or a function. It determines the lifetime, visibility, default values, and storage location, which helps us to trace the existence of a particular variable during the runtime of a program. Storage class specifiers are used to specify the storage classes for a variable. The syntax is that to specify the storage class for a variable, the following syntax is to be followed. That is storage class, then variable data, type, then variable name. So like this we have to write the storage class, then the variable data type, and then variable name will be allowed. In C++, basically there are 6 storage type of classes. First one is auto storage classes, second is register storage classes, third is external storage classes, fourth is static storage classes, fifth is mutable storage classes, and sixth is thread local storage classes. Carefully observe this table. We are explaining that C++ storage classes. The storage classes, we are comparing also keywords, lifetime, visibility and initial values. So storage classes, for example, if you go for the automatic, so for automatic storage classes, keyword is auto is used. The lifetime is function block, only a function block. Visibility is local and initial value is a garbage value will be considered. If you go for the external storage classes, the external extem is the keyword and its lifetime is whole program, and it will be observed as a visibility as a global and initial value will be zeros. And then static class, the static, the static is the static is a keyword and this lifetime is whole program and visibility is a local and initialization is 0. Register class, that is register, register, the keyword is register. This lifetime is function block and it is also visibility is a local and initial value will be garbage value. Mutable. For the mutable, keyword is mutable, mutable. The lifetime is class. The visibility is local and initial value will be garbage values. Thread local. So keyword is thread local. After the thread, you have to use the underscore and you have to write the local. So this is the keyword for the thread local. The lifetime is whole thread. So complete thread is the life cycle. And visibility is local or global. It can act as a local or a global because it depends on the whole the thread where you are written. And initial value will be garbage value will be the initial values. Storage classes in C++ define the scope, visibility, and lifetime of a variable and function. The main storage classes are auto, register, static and external. Let us see the auto. Scope is local and lifetime is temporary, visible only within the block in which it is defined. Usage is that default storage class for local variables. Example function is that void function. We have to write the function name, open the bracket. Here, auto int a is equal to 10. So, a is a variable, is a local variable which is declared as an automatic. So, auto keyword is now also used for type interfaces. So, auto x equal to 10, for example. So x is a type integer. Register, so it is a local and lifetime is temporary. Usage is that suggested to compile that the variables should be stored in a CPU register for fast accessing. Though the modern compilers often ignore this hint, cannot be used with a with and address of the operators. For example, void function, open the bracket, register int count equal to 0. So count is a variable of integer type and it is a registered which will be stored in a CPU memory. Third one is static. It is a local or global. It acts as a local or global and lifetime is permanent. Variables retain its value between the function calls. Very carefully observe that static is a permanent and variable retain its value between the function calls. Usage is that local static variables they retain their value between the function calls. For example, void function, open the bracket, static integer count equal to 0, count plus plus. So count retain its value across the calls. The global static variable are a function limits to the file in which they are defined. Internal linkage. Static integer global variable equal to 5. That is a global variable is a variable name that is declared as a global and is assigned as a value 5 and it will retain its value as a 5 throughout the program. External, external is in a global, lifetime is permanent. So usage is that indicate that the variable or a function is defined in another file or a elsewhere. Used for linking global variables or a function between the files. For example, in an external integer global variable. In file 1, we have declared that external integer global 1 declared as global variable. And in file 2, if you call it as integer global variable equal to 10, the definition of global variable will be defined. Thank you.